And it's not your last chance. We might give you another chance to say something or something, but just anything that you feel like you need clarification on. Reaction kinetics. And at what exactly?
Determine order reaction.
Order. To determine order. Okay.
The table. No about table.
Only my tables are using my tables are. I'll just give a brief background. Then we will know what we're on. Can we look for an example? You're going to determine order. But the idea is that the order of an experiment, and the order of a reaction rather, is determined experimentally. You have to be in the lab. You have your reagents A and B to give C and D. So if you want to determine the order of a reaction, what you want to do is you want to change the concentration. That's the whole scope. Change concentration and see what happens. And see, that's the statement. And see what happens. With what? What happens to, you can say, to rate. So you need to have a way to measure rate, and you need to tamper with concentrations. That's the whole scope. If I change the concentration of A, what happens to the speed? So you need to have a way to measure speed. Different ways to measure speed, doesn't it? Yes. Many ways to measure speed. Your colorimetry, you can use mass, and it. Yes. So this is the idea. So it's determined experimental logic data. So you need experimental data. Someone must have done the experiment. So let's have an example of that information. So that information should tell you concentrations of these and what happened to the speed. So usually they double the concentration, then double the concentration of A and see what happens to the speed. Does it also double? If nothing happens, it's what? Zero order. If it doubles, then you need to interpret. And if you calculate, you can just interpret. If it doubles, it triples, you need to figure out. Doubles and quadruples. For A, you have to change B. So the other thing is that when you change the position of A, you have to hold the position of B constant. And then when you tamper with B, hold A constant. So let me take an example. You want to know? No example actually. Oh, okay. One question paper. Yeah, we are going to gamble because if you make a mistake in copying the numbers, it will make sense. And so question again, let's do it together as a class. Hydrogen reacts with iodine at constant temperature according to the equation. Preparation date, which year? My questions are because there could be a mistake with your copying with but anyway, let's just see if we can determine something. 2HI. This is the reaction. Hydrogen reacts with iodine at constant temperature according to the equation. The table shows the results of experiments used to investigate the kinetics of the reaction. Pane 4 experiments. So the table is experiment. Concentration of what? Concentration of hydrogen. Concentration of rate. Concentration of hydrogen only. Rate. So what was the question? We are not going to do the whole question, are we? And so plot the graph of the rate of reaction against concentration of hydrogen. This one you can do, isn't it? And so plot the rate against concentration. No first question. This one. Plot this against this. Must be easier. What are my figures are in plot? And it those are the question. So the numbers are 1 times 10 to the power minus minus 3, and it. So for the sake of time, I'll just say para by 2 about by 3 by 4. So about 4 experiments. 4 times 10 to the power. Then kuna a minus 6 sagatina 6 times 10 to the power minus, is it? This one is minus 7. The first one is minus 7. Then power 1,2 times 10 to the power minus 6. A arbitrary 10 to the power minus 6. And then so 1,2 1,8 times 10 to the power minus 6. So I just better 2,4 times 10 to the power minus 6. 1, 2, 3, 4. Those are guided. Don't take branch. So the first question I was plot, you're supposed to, it's about scale. Is what I determine worker. And is it? Which scale can I use to plot this? And is it? For plotting a graph, you have to be able to do that. Start with the reason, the order of the reaction with respect to hydrogen. So let us say, what is the order of the reaction with respect to hydrogen? What is the order of the reaction with respect to? So we are focusing on hydrogen. Yes, the Ghana water we are using the hydrogen. But how come? Anyway, let's see. Let's try to figure out what's happening. But usually, you're also given the position of I2, isn't it? Yes. Usually, this table is presented that way, isn't it? But anyway, how are the factors changing here up? What about what double? The concentration? Usually it's the double, triple, or quadruple, isn't it? So the first is 1 times 10 to the power minus 3. The second experiment, what happened? In the second experiment, what happened? It was doubled. 2 times 10 to the power minus 3. Isn't it? Doubled. But now let's figure out what happened here. How did the rate change? By which factor? Isn't it? So it doesn't. Let's divide those numbers, isn't it? Yes. The larger one divided by the smaller one. Which one is large? 1,2 times 10 to the power minus 6. Divided by 6 times 10 to the power minus 7. So try and plus 8. By what factor did the rate change after doubling the concentration of hydrogen? At that stage, you can figure out the order. But it was tripled, but it was quadrupled, that is. We can go for these even numbers. It was quadrupled and we can check what happened here, isn't it? But it was times 1, but times 4. So we can compare these, isn't it? And this was that the challenge? Could no pick on which experiments? Because normally you want to look at where was hydrogen held constant, isn't it? Where was hydrogen doubled, etc., isn't it? But you can still do something with these numbers. What happened to the doubled? By which factor? How are these numbers related? By which factor? What divided? 2. Huh? If I divide this into this, later 2. You don't seem to be sure. Buy a calculator to it. What about the answer? If I say this minus 6 divided by this one is the smaller number, isn't it? Getting into this larger number, how many times?
2.
Huh?
2.
2 times?
Yes.
Yes, so our rate is also doubled. Those are sorry. When we double the concentration, our rate doubled. So how do you interpret that? If I double my concentration and my rate doubles, you must have a statement that allows you to make deductions. What does it mean if my concentration doubles and my rate doubles? Yes.
Concentration is directly proportional to rate.
And what does it mean? Yes, it's directly proportional to rate. Yes, true. But what does that tell you about the order of hydrogen? The order of